Hello, everyone, and welcome to another episode of Simplified Network Automation with NetGru. I'm your host, and today we have Stien Vanderhallen. Stien, welcome to the stream. Lovely to have you
Hello.
here. Tell us a bit about yourself, what you do at Cisco these days, and how are you, first of all?
Well, I'm doing great. Thank you.
Good to
How are
hear.
you doing, Adrian?
I'm doing great too. Thanks.
Good, good. So yeah, I am what they call a industrial IoT solutions engineer at Cisco. And basically that means that I take care from a technical side of our sales opportunities we have in Cisco. 1.5 years ago, I moved from Belgium, where I'm originally from, to Spain, because basically I'm taking care of the southern countries in Europe, so Spain, Portugal, Greece, anywhere where it's warm.
Nice.
And in terms of technology, I am mostly dealing with industrial customers, so like factories or electrical substations or yeah, anything that's not carpeted, as we like to say. Uh, yes. So yeah,
Good
that's what
stuff.
I'm mostly taking care of. I have to say, before this, or before being in this industrial IoT architecture, I was mostly active in DevNet,
hmm
so
We've had you at
programming.
several Cisco Lives at events. I mean, that's kind of how I've got to know you, just going to
Exactly.
events. So, yes, tell us a bit about that side of yours too.
Yeah, sure. I mean, it all started when I was in university. I kind of got hooked on the programming and the computer sciences. And then from there, basically, I started in Cisco in the CSAP program 4 years
Okay.
ago already. Yes.
So that's for fresh graduates program for folks that don't know, right?
Exactly. The sales kind of young graduate program, indeed. And that's how I got in touch with all different architectures. But DevNet was, for me, kind of the one that stood out because of my background in computer science. So I got to spend a year and a half in the GVE team, so virtual engineering for DevNet, where I got to do a lot of cool, smaller projects supporting the sales teams. And yeah, that's also how I started speaking at some Cisco Live events. And that's where I met you.
Cool,
Yes.
cool. So, that's nice. So you do have a software developer background. You're not like some of the folks that are, networking background and they're jumping on the automation bandwagon. You come with a software development background and kind of tacking on top of that networking and IoT.
Exactly. For me, the CCNA stuff was new when I
Right.
started at Cisco, not the DevNet stuff. I know that there's a lot of
Right.
SCs who do it the other way around. But yeah, for me, the automation came first, and I think especially with these industrial customers, it's interesting because they might not even have heard from automation, right? Like most
Right.
Cisco customers, they might be okay with some automation and programming now in their environments, but coming into a factory with Python or Ansible, they show you the door very quickly.
I can imagine. Yeah. So it's an uphill battle for you for sure. But it's good to see new generation of engineers coming actually from a software development background. I'm happy to see that. All right. So working. Oh, Matt Schmitz. Hi. Hi, Matt. He's there. He's watching on LinkedIn.
Oh, he's a colleague
Jeff.
of mine from DevNet. That's very good
Yes.
to see. He's
That is a
still a
friend.
fan. Good.
That is a fan. He's been on the stream too earlier. We've covered with him. It was like a catalyst center use case. So VLAN provisioning, something
Very
that he did in GV, like some of the projects that you've done. All right, Steen. So tell us a bit about what we're gonna talk today. So is that was how this project came to be? how did you get to work with this specific use case?
So I'll start with saying that the use case that I'm going to show, by no means it's something that any of my customers actually have running. It came more from the idea of us trying to use the edge computing capabilities of the Cisco switches and routers in these industrial customers, because they're more the ones to be open to having these edge applications, right? Where an IT customer, they might be open to just put everything in the cloud or in some big data center or whatever. With an industrial customer, it's more likely that they're open to an on-prem kind of deployment of whatever that they're doing. And so, from an automation perspective, and so what I am interested in, that usually means IOX applications and basically edge computing on Cisco devices. And so we're starting to include this more and more in kind of the pitch that we give to this type of projects. And because customers come from different backgrounds, different use cases, different whatever, they have some very nice ideas of virtualizing whatever they have in a factory or whatever they have in an electrical substation, but they're kind of they don't know where to start, right? They're like, okay, it's a great idea to be putting my boxes in another box, let's say, but how do I start? And this is where this kind of idea grew of me to do a Cisco live session, actually,
Hmm.
where I kind of go over the most basic programmability features, but the ones that are interesting to an industrial customer. So I want to stay away from like the AI hype on this one. I want to stay as low
For
level as
now.
possible because this is the kind of stuff that appeals to the OT environments, to know every line of code and what it does and how it's useful and how it can solve a specific business case. So the idea I'm kind of starting from is this concept of, okay, let's say in a factory you have 15 robots in a packing machine, let's say.
Hmm.
Um, could we maybe just have one robot that is controlled by an edge application and can do multiple functions, right?
Hmm.
That's an advanced kind of result of what we could do. Another thing is in electrical substations, you have these transformers that could kind of regulate the voltages that are flowing in and out of these substations, which usually are these little boxes that have been there for 20, 25 years. They could break, they don't really get updated, and so on. So they're using edge computing. You could go to, again, like a virtual deployment of such an application on industrial switches or industrial routers. So those are some kind of end points that could come from customers. And what I would like to kind of show today is a very, very boiled down, how do I virtualize a temperature sensor that could be on a machine. So what I would like to do is first kind of build a workstation as it would be in a factory,
Hmm.
monitoring the temperature of whatever is around, let's say, and then very simply take this fake workstation that's on the Raspberry Pi and put it on an industrial router.
Okay.
Basically, taking this idea of, yeah, if I have a box standing in my factory, could I virtualize its function into an industrial router?
Okay. All right. So temperature sensor. What else could you have in there? Pressure sensors, I guess. Air
Yeah,
quality type of
pressure,
thing.
humidity,
Humidity.
stuff like that. Environmental sensors is, I think, the most basic application. But you can do anything. You can start controlling robots from your router as well, if you want to do that.
I see. Okay. So how would you do that? I know there's like an interface was like SCADA. It's like a different interface that you communicate with these robots, right?
Right, right. In the industrial kind of atmosphere, you usually have some specific legacy protocols or older protocols, usually working on a serial interface, not the Ethernet IP that we know. In this case, I brought a sensor that's I2C sensor. I don't know if that makes sense to you or not. It's like a serial protocol. Yeah.
I see. Okay.
Okay.
Want to start sharing screen and have a look at your application?
Sure. We'll do that. I'll let me just make sure I'm sharing the right screen.
The right thing.
There we go. Uh,
Uh,
yeah.
all right.
Do you see my screen?
Yep.
Okay, so this is basically the you're seeing the picture, right?
Yes.
Okay.
It's like a Raspberry Pi
Exactly,
with the
exactly. I
sensor
just want
attached
to
to it.
show yeah, this is a picture I took like 10 minutes ago of what's actually in front of me here or here next to me. So we have just a Raspberry Pi, and right here you can see I've pinned in um, a few pins towards this little sensor over here. Do you see my cursor?
Yeah.
Yes.
And that's a temperature sensor. Yeah, I can even see the
That's
cursor
a
that's
yeah.
here.
That's a temperature sensor that's communicating over I2C into the
Mm,
Raspberry Pi. The Raspberry Pi itself, it has an I2C. I mean, it supports incoming I2C communication. I just had to basically connect the right pins to each other over here, and then it's exposed to the Raspberry OS in
mhm.
just a serial port, and that's the one
With
that we're going to be
GPIO,
using.
was it? You can read and data from
Exactly.
IO ports, right?
Exactly. Yeah, I'll show in a moment the code I'm actually using in Python to read out these temperature values. But yeah, that's basically what we're gonna start from, and then later on we'll move to an actual industrial router. But as I said, I want to keep it as low code as possible, so we're gonna go through the actual code that's running. You also see my coffee over here, my glass of water. Okay, and let me just start here and connect to the Raspberry Pi. It's just plugged in with an Ethernet cable into my PC.
Hmm.
I can connect over it directly. I don't know if this is big enough.
Um, it is. Yeah.
Yeah?
Yeah,
Okay.
I can see.
So I'll just log on. Here we go. So I'll go into my documents and I've set up a directory for you. But right now,
Okay.
there's not really anything in it. There's just this IOX client binary that we're going to use to transfer our code kind of from the Raspberry Pi into the industrial router later on. And then I have some files that are the backup for whatever we're about to code now in case something goes wrong. But okay, we'll just start with, I guess, the most ugly part, which is how are we going to read and the actual temperature value
Hmm.
into some Python code, right? So I'll start a file, uh, temperature.py, and then I have prepared here what we're actually going to do. There we go. So basically, what we're going to do is use this SMBus library for Python to work as a driver for this I2C um, protocol coming in from the temperature sensor. So basically, this address is just something I found on Google telling me how the GPI opens on the Raspberry Pi correspond to the actual I2C driver on the Raspberry Pi. So this is, yeah, something I can hard code.
Mm-hmm.
And then from there, I have to be honest, this is all just code that I copy pasted from someone who was using the same temperature sensor. As you can see, it's quite ugly. Yeah? So there are some hex values over there. I need to do some shifting of the serial bits that are coming in to get to an actual temperature. In the end, I need to do some calculations. I'm not gonna bore you with where this actually comes from. Basically, in short, if you look at the data sheet of the temperature sensor that I'm using, from there you can see which actual bits it's sending and what they correspond to, how to transform them. And this is basically just a code version of that to
Mm-hmm.
come to just a Python float for the actual temperature value. So
And
I'm
this
gonna
return the temperature in like Celsius degrees, I would imagine.
yes, we're in Europe,
Okay.
so yes. But I mean, if you want to go to Fahrenheit or
I
whatever,
can easily transform that.
I assume something over here would change because I'm doing
Mm-hmm.
the -50 over here. Yes. But yeah, so just to give you an idea of the kind of low level we need to go to when we're talking about industrial customers. This is very far from the AI that we've been talking about a lot. So it might be refreshing. Okay, so we have this one. And then the next thing I would like to do is basically set up a small Flask application that's going to use this temperature and show it in a little graph, right? So I'll set up another file. And I'll start with, yeah, some imports. Basically, as I mentioned, we're going to do a Flask application. So just a little web application that we're going to be able to reach just from Google Chrome, reaching the Raspberry Pi IP address. And then I have some helper libraries to deal with JSON objects. And I'm also importing this random library for whenever data wouldn't be available from the temperature sensor or some other error is thrown. We just generate a random temperature, which might get fun. But okay. Then I'll put the next part of the code. Here you can see we're just starting the Flask application. Again, this
Mm-hmm.
is some boilerplate code I got from the internet to start
Mm-hmm.
Flask. I think your audience is aware.
Yeah, we've
And then
covered Flask many times before.
I guess. And then, yeah, basically some helper functions to read and write a JSON file. Basically, I want to use this one to keep a buffer of the latest set of temperatures that we read. So I'm going to open a JSON file with an array where we can have it fill up with the temperature values we're reading. And then I guess the interesting one is this one, the get temperature function, where we're going to try and use a function we wrote before in this
Mm-hmm.
temperature.py to read this sensor value, gonna log the response and return it. And as I said before, if we run into an exception, I'll just generate a random value between 0 and 30. I don't think this is too crazy.
Mm-hmm.
Then, as for the actual endpoints, we're gonna show in the Flask app. I want to do two of them. One on /temperature, where we can basically see this as an API. So we could use the Raspberry Pi as a temperature server. So to
Hmm.
save from another point, but I guess the visually interesting one is the actual index app route. So the landing page of this little workstation app, where we read out the temperatures we've gotten so far. We get a new temperature and append the temperatures we had so far with this new one, and then write it back to a temperatures.json file. I don't think this is too crazy either.
Hmm.
And then, yeah, we'll return an HTML with this information in there. I'll just end with writing the main loop, and then we can go and test.
Cool. So we have the helper temperature library, well, module with the read temperature, and then you have the main.py with the Flask application, basically that starts a web server, basically using Flask on the Raspberry Pi, and you make the temperature available in a REST API-ish web page format.
Exactly. That's exactly what's happening. So, I mean, again, it's very, very simple. But one thing that we should note here as well is that on these switches and routers that we're going to do the edge computing on, of course, these are not like full-fledged servers like you find in a data center. We don't have infinite resources on just a switch to be running huge applications. So yeah, this is also why we try to keep things as simple and ugly as possible. I like to say that the beauty of this industrial IoT and edge computing is that it's so ugly. So you're going to see this in the index file that we're actually going to see. I think one last thing I still need to do is the temperature.json, and then including the HTML file. So I'll do that now. Very simple. I'll just initialize the application with an array of all 0 temperatures.
So it's like a seed file for you, basically, right?
A what? A seed file? Yes.
A seed file, yeah, just
Yes,
to get started.
exactly. And then from here, the temperatures that we're about to measure are going to move up into this array, so we can show a little graph of how the temperature is evolving. Now, as for that graph, I am going to use a JavaScript library. So I'll just copy that in as well. I mean, you've talked enough about Flask. I don't need to explain the creation of like a static folder and a JSON folder and within there. So I'll just do that. And the library we're going to use, it's called charts. So I don't have to take care of any front-end stuff. Again, I just took this from
Yeah, where'd you get this? It looks like quite a bit of JavaScript.
it is a lot. I mean, I just got this on GitHub,
Okay.
trying to find some library that's gonna allow me to easily show a graph. So here we are. Oh, there we go. So we have the JavaScript library. Now we just need the index.html. As Flask asks us to. So I'll make this index.html, and then we can take a look at where we're actually showing this chart. There we go. So, I mean, again, very, very simple HTML page to serve as a front end. We'll just do a text about the current temperature and what it is. So I'm using this, what is it called, Jinja variables, to put that in. And then I'm going to use this chart script, as you see here, to inject the JavaScript that we just pasted. I'm making a function make chart, where basically I'm getting the temp chart element, which you see here in this canvas. I make it a line graph. And then as for the data points, again, I'm using Flask, so I can use Jinja variables, which is this temp data over here that's eventually going to be passed into this function. And so here it's called temp data. I can give it a label. I gave it historic temperature. I gave it a random color. And then I put filter true. So the graph will be filled below the line following the temperature. And then these are some, I mean, front end stuff that I don't really care about dealing with, like if I make my browser bigger or smaller. Anyways, that will be
Right. Straightforward.
Very straightforward, very simple. But for an industrial guy, this is rocket science. Okay, I think now we have everything to run the main.py and look at the actual application. There we go. Great. I'll just open a browser into the same. It should be this one. No, it should be 8,000. I think it's running on 8,000. Yeah. No, it's not this.
It's a different IP address, though.
Yes.
254, yeah.
There you go. So yeah, here you see the actual app running now as it's on the Raspberry Pi. You see on the top the text that we made in the beginning, and then in the bottom this graph, which looks beautiful because of the JavaScript that we plucked from the internet. And basically this page refreshes itself every 3 seconds with a new temperature value. What I'll do now is just I'll hold the temperature sensor in my hand. So
put your finger or something or hold it, it's gonna go up.
Yeah, I'm just holding it in my hands, so it should be going up. Yeah, there we go. So I can use this to check if I have a fever now.
That's what I was thinking too, actually. Yeah, as a thermometer.
Yes, exactly. Okay. So this should be fine. It should be 24 degrees Celsius approximately in this room, and I think that's correct. Okay, I don't know. I think this is the main part of what we should do to kind of set up this virtual workstation. We can just now pretend that this Raspberry Pi is not a Raspberry Pi, but it's some kind of box that's forgotten about in a factory, but which is being used to monitor the conditions in a factory. Okay. So keeping that in mind, let's now kind of try to take away the box, and instead of having to host this on a workstation within a factory, let's see if we can move this application into an industrial router. All right.
Cool. Let's see.
Let's see how this is gonna go. Yes.
So you were saying your router is actually in Spain, right? Oh, we lost Stien. Hold on, she's coming back.
Am I back?
You're back. Yeah, we lost you for a bit.
Oh, sorry. Yeah, you were gonna ask something.
Yeah, so your what is it? In 1101 is actually sitting somewhere in a lab in Madrid.
Exactly. It is. So, yeah, I can show you. The device that we're gonna use is gonna be an industrial router, the IR1101. Um, well, we can say it's more of like a gateway. The way I use it is it has like a 5G module inside, so I can basically put it anywhere, power it on, and then I use this IoT operations dashboard to basically talk to it. Um, without going into the Cisco marketing pitch, let's say, I'll just mention that we have this application, which is also an IOX application. It's called Secure Equipment Access, that I have deployed on this router. And this one is basically going to give me remote access to the device and any device behind from the cloud. So if I go in here to my remote sessions, it basically gives me the different ways I can connect to this router, either using SSH or using a HTTP connection to connect to the web UI on the router. I'll just using another IOX application deployed on the router itself, which is connecting back to this cloud application. It's a pretty nice way to be able to connect over SSH without having to install any VPN clients on my computer itself. So, for example, I now connected over SSH to to a kind of loopback interface on my industrial router. And so that means that I'm basically inside the router right here. So I have an SSH connection set up from my browser. I don't need to worry about how to do that from my computer. I'm just gonna check out if everything's connected. So here you can see I'm using a 5G connection back, and then on the downlink I just have some loopback interfaces and some VLANs connected. But I mean, this is very much a a lab setup that we're using here. So yeah, this is going to be the one where we're going to deploy this application. Let's first build this application, because one kind of implication, let's say, of doing edge computing on Cisco devices is that we like to make everything in a Cisco specific shape, right? Meaning that you can not just take a Python script or a Docker application and put it on a Cisco router. You kind of have to build a wrapper around, which we call an IOX wrapper. So what we're going to do now is on the Raspberry Pi itself, just because we have it available, you can do this anywhere, is we're going to turn the whole application into a Docker container. So we have everything contained in one image. And then around that, we're going to put the IOX wrapper. And then we take the whole IOX package and we're going to deploy it onto the router directly. So to start that, because I said we're gonna package this application into a Docker container, we're gonna need a Docker file. So let's just set that up as well. Again, I'll just copy it. And here again, we have to be mindful of the fact that the routers and the switches that we're using for any type of application are usually quite limited in resources. both in RAM as well as storage as well as whatever. So in choosing like the base image for what we're gonna do, I tried to find one as small as possible, so Alpine with Python
Mhm.
installed. And what's specific here as well is the CPU architecture of the IR1101. It's ARM64, so we need to take care of that as well. And it's not very simple. Like for example, my Mac that I'm on now, obviously it doesn't have an ARM64 architecture, so that's another reason why we're using the Raspberry Pi itself to go and build this Docker file, because this one does have ARM64 and therefore is able to match the IR1101. Then we're going to install some libraries. So in this case, requests and Flask.
Mhm.
And we're going to expose two ports, 8080. Basically, one to have the front end, so the little graph that we just saw, and then 80 just for this slash temperature API. So we can use this virtual workstation remotely from scripting as well. I'm going to copy all our files. And then here you have some specific labels that Cisco has defined for IOX applications. These are basically just labels that are going to be used by any Cisco management tools to automatically give a name to your application. And to, I mean, for instance, this version, this is all just bookkeeping information. I could leave this out as well. Especially the author link and name. I even left it empty. Again, I just copied this from other boilerplates that I have. I put the CPU architecture, the resources that I want to have assigned to this application. I've put this all in these labels to have it in the Docker file. But again, it's not all of these are essential. We're going to see later when we actually put the application on the router, there's going to be other options to change the amount of CPU and memory and disk that are going to be assigned to this application. One thing I have to assign as well is an Ethernet interface, which is going to allow my application to be able to be reached
Mhm.
from the outside. And then finally, I mean, we've seen many Docker files before. We're just using the entry point to start this main.py, so just like we did earlier on the Raspberry Pi itself. All right, so that's going to be our Docker file. We can just go ahead and build the image already, I guess. So I'll go ahead and do a sudo docker build tag Stien / workstation IOX version 1, and then I want to start from here.
All right, so this is building a Docker image that you're gonna feed into the IOX client, right? To wrap that image into something that the router can understand and work with.
Exactly.
Okay.
Yes. The routers don't allow me to just randomly send a Python script into the router. I need to have this kind of layer in between, which is IOX. Oh, I need to connect to the internet to pull the Alpine image. Let me try again. Now we're going. Yes.
Okay, so you had a different default route that was pointing somewhere else, not to the internet.
Exactly. My default route, it was set on the Ethernet link that's going into my laptop, and this one's not allowing the hop further into the internet. So what I just did now is I deleted that default route, and then it's going to use as a default route the Wi-Fi module that's on the Raspberry Pi, and that one is just
Mhm.
connected to the Wi-Fi I'm connected to.
All right, so it's pulling Alpine, right? And there you go, it built the image.
Exactly. There we go. So now, yes, we have all our layers. So we're going to go ahead and turn this into a IOX wrapper, right?
iOS
An iOX
application, basically.
application, yes. And I mean, there's a few different ways to do this. Um, but basically, what I usually do is I extract the layers that are in the Docker image into a rootfs .tar, and then I use that one to do the actual IOX wrapper. So I do a sudo docker save rootfs.tar, and then based on those layers stored in the rootfs.tar, we build the IOX application. Let me just copy the name I used. This usually takes a couple of seconds. I believe the IOX client, so the CLI client you can use to interact with IOX, it also allows you to directly from a Docker image package into an IOX application. But I've seen that doing it this way, it gives you a little bit smaller applications.
I see.
So that's why I'm doing that. But yeah, there's 1,000 different guides. I also link them on the GitHub.
And yeah,
To
we'll
give you
share
the
the GitHub on both LinkedIn and YouTube folks here as we get closer to the end. And there you go. And Hakan Volkan, hello. Thanks for joining us.
hello.
All right. So rootfs.tar, the file system is extracted, is saved.
Exactly.
Now iOX client.
Yeah. So now we want to use IOX client to build this wrapper around. And the one prerequisite we have for that is to create a package.yaml file. This is something IOX specific that we're going to have to do. And it looks like this. So basically, it's just a YAML file which has the same kind of labels or info about the application that we saw earlier in the Docker file. So you can choose to give your application a name either here or when you build the Docker file, or even when you're actually putting the IOX application onto the router, you can even change the name. So there's many different options. I'm just showing them all. The important part is over here, where you're kind of telling the IOX client which type of wrapper it's supposed to put around your application. So we're telling it here now that we're having a Docker application, that we have an ARM64 CPU architecture that we want to go to. And then in terms of resources, there are some predefined kind of profiles that you can assign to your different applications. And this is just a default. I don't know by heart how many megabits of like memory and storage you're going to get. But again, this is all documented on DevNet. It's just a matter of making sure that it's included in this package.yaml. Then, because I want to make my application reachable from outside of the router, I'm going to add this Ethernet 0 interface as well, and expose some TCP ports to make, as we said, the front end and the REST API available from the outside. And then finally, we're going to tell IOX clients to go look for those Docker layers that we extracted earlier in this rootfs.tar. And then what the target or the entry point is going to be for our application. So yeah, this is kind of a YAML version of the Docker file, almost.
Yeah, it
Almost.
looks like it.
Exactly. But basically, you can think of it as a Docker file for an IOX application. So not in the standardized Docker kind of way. Okay, let's get out of here. Let me check. We have the rootfs.tar, we have the package.yaml, and we have the IOX client installed here. So right now what we can do is use the IOX client and do a package of the directory that we're in. And now it's basically generating this. This IOX client, again, it's available for download on DevNet for different types of operating systems. Because again, your IOX application needs to be built on a Raspberry Pi or on whatever device that has the same CPU architecture as the one that's your target. So in our case, this IR1101.
I see. So you cannot basically build an ARM64 IOX app on like an Intel x86, whatever it is.
Yeah. No, you can't. So, I mean, this is important, right? If I would take this application and try to deploy it on a Cat9K, which does have the x86 architecture, it's not going to work. So when I upload it, it's going to get a little angry at me for doing that.
Okay.
So you can see also that it's giving you some comments, right? That it's looking at this package.yaml file. It sees what version it is. It's kind of validating that it's made correctly and so on. And then it starts generating the actual package. It's going to end up with a tar file, which we're then going to use to upload into the router. Maybe while this is finishing, we can already move into the router and get ready to upload the package later on. So here we go. Again, I'm using this secure equipment access. So from the cloud, I'm able to access the web UI of my router. Let me just log in. The idea is that usually you would do this from a local management controller, from like a Catalyst WAN manager, or earlier from the IoT operations dashboard, or even from a Catalyst center or whatever. So you do it in like the whole, the centralized, automated, scalable,
Controller based. Yeah.
Exactly. But again, we're staying away from the marketing stuff, and I just want to kind of give the tutorial to do it as bare metal as possible. So we're using just the web UI included with the router. And then here, if I go into IOX, I need to log in again because it's kind of a subsystem of iOS 16.
And Julio Gomez, such an exciting demo indeed. This is pretty really cool. So thanks for joining us, Julio.
Thank you, Julio. Gracias, I should say. Okay.
All right. So here's the applications that are currently running, right?
Exactly. So now you can see that this secure equipment access agent, it looks very cool in the cloud. But in the end, it's just an IOX application that's deployed on top of my router. And then over here, I mean, I cheated a little and I already moved another version of this application into the router so we could finish on time. But over here you can see, so this workstation, it's basically a packaging of the same stuff that we saw on the Raspberry Pi, but now it's moved onto the router. So from here, let me just show this management button. Here we can see the same kind of stuff that we saw in the package.yaml and in those Docker file labels. So you can see how much CPU is assigned, how much memory, how much storage on the disk, the network configuration I can put over here. Should I want to change or make static the IP address that's assigned to this application, I can do that over here as well. But yeah, that's kind of the stuff that happens over here. You can also monitor the memory, the CPU. Let's see if our package is done, or at least the new one is done. All right, so the IOX client, it's now done. It generated this package.tar file. And then basically what I did earlier today to upload the package into the web UI is I just did a secure copy
secure
of
copy.
Yes, of the package. Let me copy this because I don't know by heart. Well, no, we can figure this out. Stien at the IP address .23, and then we can just do a print working directory here. And that's it, except I need the
package.tar, yeah.
And then I need
copy to the actual.
Exactly. Let me just make this a little bigger. There we go. I mean, this is very simple, right? But again, because we're dealing with different CPU architectures, we need to do some of this ugly stuff, moving files.
Okay, so you move on your Mac with that secure copy.
Yeah. Here on the left, I'm just on my Mac in a folder called Raspberry Pi app. So I moved the package.tar over there. And then if we go back into IOX, what we can do is do a workstation 2, for example, browse. And then if I go into this Raspberry Pi app on my PC, you'll see this package.tar being copied there. And then, I mean, you see it's from 52.
1 minute ago, yeah.
Exactly. So I would upload, and then, I mean, I would end on the same thing as this. It takes some time, so you can just take my word for it that this is the same application as the one that's over here. Here you can also see this IOX Docker Python web sample application. This is something that was taken from this package.yaml, where we defined the descriptor, let's say, of the application. This version as well, the profile, whatever. This is all metadata, right? The most important thing is this CPU architecture and the fact that there's a Docker application inside. Anyways, that being said, let's do 1 minute of going back to secure equipment access. Because another connection that I set up, it's not just SSH into the router or to the web UI using secure equipment access. I'm also using this SEA IOX application to show the other application, the virtual workstation that we have now, right? And that's the connection that you see over here. So this one, it should be the front-end application that we just saw. Because it's HTTP, sometimes Firefox, it gets a little angry about actually opening this. So this might take a while to actually open. That's why, again, I cheated a little bit and I saved the HTML from earlier, from what I saw once this loaded. But basically, it's the same thing as what we saw on the Raspberry Pi. You see a graph with like the evolution of the temperature. Because right now the router it's in Madrid still. I'm just putting a temperature 7
Okay, or the random
hard code.
generation.
Yeah,
Oh, just okay. All right.
yeah,
So yeah, because I was about to ask, but because I saw all private IP addresses on your router on your IR1101. So it's like,
yeah.
how does it establish connection back to the cloud? But it's through that secure
Exactly.
agent, right?
It's
You
secure
basically run
equipment access.
secure equipment access. So there you have an actually application running on your IR router that connects back to the cloud and exposes applications, exposes ports, give you the option to SSH into the router, gives you the option of actually having also web access to it. I see. Because it was strange to me. It's like, hold on, it's all private IP
Yeah,
addresses. How is the cloud reaching this device? But it's the actual agent that establishes a connection.
exactly.
Uh,
It's kind of like a proxy on the router
right.
itself.
Gotcha.
We basically sell it from the industrial IoT business units to reach devices within a factory. So the ones that are
Mhm.
behind a firewall or whatever, because
That's,
we
yeah.
usually see like duplicated IPs and so on. So you might want to have a connection close. Now it loaded. So now we see the actual application that's on the router.
On the IR, on the product itself, yeah.
Yeah, and so we're using the SEA application to actually look at it. It functions as a proxy for the rest of the applications. Normally towards machines that are behind the router, but we in the team are using it a lot for this purpose to be able to reach our routers from distance and do some playing with them.
Nice. All right, cool. This is really nice. So, folks, I've put the GitHub repo with pretty much everything that Stien has showed us in the comments. That's on YouTube. Once the recording is ready, we'll also put it on LinkedIn. Let's go like this. So we'll have the link with the GitHub repo on both YouTube and LinkedIn. If you have any questions, drop this in the comments. Let us know. This was really cool though. How to build basically an iOS app from scratch, and it was just reading a temperature sensor in this case, but it could be whatever type of sensors you have, whatever type of data. Pretty straightforward, right? Just some lines of code. The biggest hurdle from what I've seen was like the JavaScript thing. That was the longest by far dump of code in there, but the Flask application very straightforward. Um, the packaging, creating the Docker file, right? Nothing fancy, just regular Docker, and then kind of a YAML version of that for the package.yaml that you can feed into iOS client, create your iOS application as a tar file, load it up on your device, start it, manage it, assign profiles to it on how much memory, CPU, disk you want to associate or to have dedicated for that app. You can start it, stop it, right? Can you troubleshoot it? You have like
Yeah, you have
access
some.
to like logs or
Yeah, yeah, you have some logs. So whatever we saw while it was running on the Raspberry Pi, so basically the Flask kind of logger that you always see of which requests are coming in, I can also see that on the web UI.
nice. All right, and then secure equipment
Equipment
access. Uh,
access. Yes.
yeah, see secure equipment access. Make sure you have it in there. And Oh, Jeremy, nice demo. Yeah, thanks for joining us, Jeremy. Yeah, indeed, it
Thank
was really cool demo. Thanks for showing this, Stien.
It's very simple, huh? But
Yes,
at least
it's
for me, it's
straightforward.
necessary. Yes.
It's as long as you follow the steps, right? Because there is a certain progression of steps with creating iOS applications. But as long as you go through the motion of following the steps, I mean, it's gonna work. Because I
Yes.
remember trying to get iOS apps running. This was like 4 or 5 years ago. It was the same thing, right? iOS client for Mac, you have it. iOS client for different platforms is there. Download it, run it. But yes, be mindful that the architecture of the CPU on which you're running iOS client has to match the architecture of the CPU of your IR device or your IoT device, because it's not going to work if not. All right. Any final words, Stien, before we wrap up?
Oof. That's Are you asking me for some kind of slogan like at the end of the news?
No, just where can people find you next? Are you gonna be at Cisco Live Amsterdam, I would imagine?
Cisco Live Amsterdam. If all goes well, I'll be there and I'll bring the Raspberry Pi again and bring the actual router. Hopefully, if I get it back from Madrid, and try to do some more cool stuff. A few years until we're gonna be doing AI on these machines, but we
Yeah,
did the
'cause I
baby
mean they're
steps
pretty
now.
limited at this point. Like you said, resource, they're very limited because the main purpose is to run small edge applications, right? On these like small devices. You're not gonna have large GPUs because the whole device is, it's like that big. I mean,
Yeah,
GPUs are at this point larger than the device, like
exactly.
the router itself. So you cannot fit an NVIDIA GPU at this point in IR. It's not
No,
possible. But you know, maybe in a couple of years, who knows? These
exactly.
GPUs become smaller and they can probably fit them in IR devices too. But until
I mean,
then,
and the use cases need to come as well, right? The use cases we
right?
see now are still guys who want to see like the red and green lights on whatever is happening in the factory. They're not yet interested in doing like digital twin and whatever self-healing networks. They're rather scared of it. We're now talking about virtualize a
I will get
workstation.
there.
Yes, but we'll get
We'll
there.
get there. It's just gonna take a bit of time. Yeah.
Exactly. Exactly.
Uh, all right. Well, thank you so much, Dean. Thanks, folks, for joining us. Next week we'll be back. We'll have some smart licensing session. It's gonna be pretty cool. I'm sure folks are struggling with smart licensing, or I mean, I know some folks that have been struggling. So we'll have a session to help you with that. Coming up, be on the lookout on LinkedIn. As usual, we'll send out the link with the title abstract. It's coming up later this week. So till then, thank you, Stien. Thanks, everyone. And see you in the next one. Take care, folks.
See you. Bye bye.
Thanks, Dexter.